Hey friends, Azure Cosmos DB for Postgres is a distributed SQL platform built on open source Postgres and the Citus extension that enables developers to build apps at any scale, and it's now generally available. And you know that means that Kirill Gavrylyuk is back on the show, and he's brought Charles Feddersen to show me how it all works today on Azure Friday. Hey friends, I'm Scott Hanselman, and it's Azure Friday. I'm here with Kirill Gavrylyuk. How are you, sir?
Oh, thank you, Scott. It's really exciting to be here. It's been a long time.
Yeah, well, it's a long time, but every time you come, you bring a bunch of great new features. You always tell me that something wonderful has happened in Azure Cosmos DB, and I'm sure that today is no exception. What wonderful things have become generally available in Cosmos today?
Well, Cosmos DB has been a really fantastic family, right? We care about each of our children, each of our APIs. We provide nurturing. We provide best experience for our customers. Today, the exciting news is we have a new baby, a new API on Cosmos DB for Postgres.
In the past, these APIs are like, hey, I'm talking to Mongo. I'm not really talking to Mongo, I'm talking to Cosmos, but my applications just work. So like I have my blood sugar application talks to what it thinks is Mongo. It's really Cosmos. Are you saying that anyone who uses Postgres can just use Cosmos and they get all the benefits of a world database, but they don't have to tell their application?
Even more so than ever. Cosmos DB for Postgres is actually, we took a slightly different approach. It is really Postgres.
Oh, wow.
What we're really doing there is we're combining the magic of Postgres in its full fidelity with the magic of Cosmos DB.
Okay, so then it's the way that you have learned how to scale Postgres combined with the work of the Citus data and distributed Postgres. So it's the best practices that we're standing on the shoulders of running a world database, but it still is really open source Postgres and Citus data.
Let me show you a quick demo. Will make it much clearer. What we have here is Azure Portal. I can go and create Cosmos DB. And we see we have a new addition, Cosmos DB for Postgres. What we did here is we used the extension mechanism in Postgres to plug in the Cosmos DB infrastructure that allows us for distributing seamless elasticity as well as global distribution, while maintaining the fidelity of Postgres. It is a Postgres engine. It is not a simulation.
Oh, wow. Okay. So you are using Postgres, but you're scaling it with distributed data and distributed queries, and then you can create Citus nodes all with the infrastructure that we're used to and that we count on for things like Cosmos.
Exactly, yes. We're using the Citus extension to do this, and Citus extension is leveraging Cosmos DB infra to scale, to do non-blocking scales, partition splits, and global distribution.
Wow, that seems really elegant. That's really cool.
So right here, for example, it is a Postgres. Like if you look at the connection strings, great. This is kind of one of the clusters. It is a cluster. I can take this connection string. Actually, right here in PG admin, you can see that it's the same. It's the same instance. It's already connected. And here I have pSQL window, right? And I can do it is a Postgres, so I can do a simple query. Here I'm using table expressions, for example, right? So not so simple query, and it works as expected. It is full Postgres. We really optimized for compatibility, right? So it is full Postgres. So I can use, for example, tdigest Postgres extension, right? I can bring extensions and take full power of this. Great. I can use Postgres functions, you name it. But the interesting part comes that now I can also distribute, right? So we already had a Citus extension for Postgres. It's an open source by Microsoft. It's a Citus extension gives you the distributed query and allows you to shard Postgres. And there is a simple syntax, right? You can create distributed table. And it's a somewhat long operation, so I'm not going to run it live right now, but you can create a distributed table. But what Cosmos DB provides us is allowing me then to manage these shards dynamically move them from node to node as the data grows, as the transactions grow. So for example, I can look at scale and I can select how many nodes I want for my Postgres. And this would be shortly after, in a couple of months, this will be completely automatic, right? So I can create this is the maximum number of nodes I want you to grow to. And then the Cosmos DB for Postgres will grow depending on the traffic, depending on the size of data, will grow and distribute my logical partitions, my logical shards across whatever number of nodes my application needs. I can also do global distribution. Cosmos DB is known for the global distribution, right? Ability to bring your data anywhere in the world to any region. So we're bringing that magic here to Postgres, and so I can go and create we're going to expand the functionality, kind of exposing more and more of Cosmos DB global distribution magic. But I can add a region, I can add any number of regions to my Postgres database, and this way take the benefit of low latency anywhere in the world, high availability as a global distribution brings.
Interesting. Now, I know that in the past, I've personally run Postgres like in a virtual machine. I know that we had other different ways to run Postgres on Azure, and this is the one I want to pick always, or just when I want global distribution? Can you help me understand what the offerings are?
Yeah, definitely. We have really three offerings for Postgres. We have a vanilla virtual machine. You can buy a virtual machine, you can run anything you want on it, you can run Postgres on it. We have great disks offering in Azure. We have a managed Azure database for Postgres Flex server that is just Postgres, vanilla Postgres, single image, single VM, but managed by us for you. It's just a VM with Postgres with different options for disk size, managed by us. But it's full Postgres, all extensions, everything.
Okay.
It's optimized for migrations, right? I can bring any Postgres to Azure and run it.
I think I've seen that referred to as Postgres single server in the documentation.
So now we have a flexible server, which is a much more improved version of it, and we're transitioning customers from single server to flexible server.
Oh, cool. Okay,
flexible is better. Right? So, and now we have Cosmos DB for Postgres. That's for if you're building cloud native new apps, right? I'm going to build a new app, and I know Postgres. Like most people know Postgres. Postgres is number one in popularity database tech out there among the open source databases. Really popular. Why is it popular? Because it's so easy to use. It's so easy for developers to use, right? It's so rich, and that's what we brought to Cosmos DB. So if you want to build new apps on Azure, you choose Cosmos DB as your database. And you had NoSQL APIs, and we had a number of them to choose depending on what you like. Now you also have a really popular relational API, Postgres. If your scenario requires ACID transactions or requires really this relational richness that you couldn't achieve with NoSQL.
Very cool. Very cool. There is an option for everyone. This sounds really, really straightforward. I like it.
We are pretty excited about this. Again, could not be a better match. The most popular relational API, Postgres, and we really took care. And this time around, we took all of Postgres. Like it is Postgres. It's not a simulation. And the best of Cosmos DB, which is the elasticity, seamless elasticity, unlimited scale, global distribution, combined together. You can start small. You can start with a single node, small node, shard, and you can expand. You can scale out limitlessly. You can do global distribution, add regions, achieve the availability level your application needs. Pay as you go, as always, and tune in for more updates. We're gonna keep adding serverless and other capabilities coming shortly, so that it will look and behave and feel exactly like other Cosmos DB APIs that you're used to and like.
Very cool. So, what other demos do you have? I know you brought a friend.
Yes, I'm really excited to bring with me Charles Feddersen, and he's going to show you a little more in depth, talk about this elasticity as well as global distribution with Cosmos DB for Postgres.
Very cool. Welcome, Charles.
Thank you for having me. Pleased to be here.
All right. So blow me away. I've seen some select star from table, but Kirill says you're going to go deeper.
Yeah, I think let's expand a little bit on what Kirill showed. I can go ahead and share my screen here. I've got a couple of demos set up, which as I said, build on what Kirill showed. So I'm in PG Admin, just like Kirill showed. It's a probably the most popular graphical development tool for Postgres developers. It's a good example of the support of the ecosystem that you have for Postgres tools running on Cosmos DB. And what I'm going to go do here is start to actually sort of build out my database and talk about some of the key capabilities that we're enabling. You're building on that infrastructure that enables that online data elasticity that Kirill talked about. So we'll go clean up what I had here, and I'm going to create a new table here. It's called ecom sales transactions. It's a bunch of columns and a bunch of data types. It's got a primary key, which is perhaps one of the most classics that are relational properties. And we'll go and actually what I'm going to go do here is I'm going to use a new Postgres extension that we've built. The extension is called Azure Storage. And what it enables you to do is load data directly into the database from cloud storage using SQL. So in the past, what you had to actually do was run like the Postgres copy command, which needed data to be on local disk. It could be a disk in a virtual machine, could be on your developer PC, but cloud storage is, the clearinghouse, really. It's the common interface for everything for data in the cloud. And so we wanted to provide an easy way for developers to access data and load data into the database just natively using SQL. Because once you've got that SQL interface, you can invoke that from anywhere. And so the Azure Storage extension has a set of functions. And what I'm going to go do here is just go run this. And this takes about, I think it takes about 3 seconds. It's pretty quick, 2.5 seconds. And what I've done here is I've actually loaded from cloud storage about 500,000 rows, 491,000 rows here.
Wow.
And so it's quick, but particularly it's easy, right? It's SQL. Once you're in SQL, you're pretty good with everything. So what I want to expand upon now is to show how we can now create a more scalable table. Right? What I've done here is I've created effectively a Postgres table. It's a vanilla Postgres table. And the easiest way to show you that is there are no shards. And what that means is the table is not distributed. It's a singular table that would run on a singular server, which is how Postgres traditionally is built, but it doesn't scale the way we want it to. And so what I'm going to do here is I've got a little app that I've set up on the right-hand side. It's in Windows Terminal, which we love. And I'm going to run this, and this is going to just dump a whole bunch of sort of verbose traffic. I'm basically generating traffic on my database at this point. You can think about this as an app. It's any app that's running, and traffic like queries, selects, or inserts to insert and modify data. And if I run the query here, what's that? 491,516. I run it again, 563. So records are going into the table. Now remember, if I look at my shards, there's nothing there. It's a non-distributed table. So what I want to do is I want to scale this table out, right? So that I can run it effectively at cluster scale. So I'm going to go run that. And what you'll see.
How can you do that while it's off? You're in the middle of production here, right? You're doing a huge amount of traffic.
That's right. So this is one of the great features that we've built and shipped at Ignite, is the ability to split shards completely online with no interruption to the app. Now, it's one thing to do this if you're just issuing select queries, that's just read. But when there are actual data modification statements running, like inserts, that's much harder. And so if I show you my shards now, we've split this. You can see at the bottom here, I've got 32 rows. So I've got 32 shards, which is the default number of shards. I can overload this and create more shards if I want to scale even wider. But this now gives me effectively fragments of a table that can be assigned to different nodes of a cluster. And that distributed query engine will continue to run unchanged. And so there's two things here, Scott. Actually, one, we scaled the data online while the app was running, but the app that has all of these queries running in it, all the queries will also just continue to run. Same connection string, and the distributed query engine will just figure that out to run at scale. So it's really, really powerful.
That is really cool. I apologize for invoking the most interesting man in the world, but he would say at this point, I don't always shard my database, but when I do it in production.
That's
That
right.
was impressive. It didn't even miss a beat there on the right-hand side.
No, it's exactly, and it can't, right? I mean, for customers, particularly a lot of ISVs who are building SaaS apps on the platform, these are 24/7 apps.
Yeah.
And so in situations where, you need to scale, and sometimes you don't, traffic changes quickly or workloads can change quickly and you need to scale. We want to enable you to be able to respond to that quickly without needing to take the app down, figure out maintenance windows and all that kind of stuff. So we think it's quite powerful.
That's brilliant.
The second thing I want to show you, and actually it cues off that multi-tenant app statement I made, is that there are a lot of customers today who build multi-tenant apps where what they're effectively doing is putting a tenant ID into every single table in the database. And so the table that we're working on here has got a tenant ID. And what I've done is I've gone and counted the rows for each tenant ID. And I've got this big tenant, right? Like one of my customers is, it could be e-commerce, it could be any class of app, but they're generating more traffic than any of my other customers, if you think about that example.
Mm.
And so what can happen in distributed systems is you can hotspot, right? Where one tenant is sort of isolated to a node, it can start to, my app on the right-hand side here finished, we'll go keep it running because the next demo needs it to be online as well. So we'll get that traffic flowing again. Sorry?
This is what they call noisy neighbor syndrome?
Exactly. You're precisely right. What happens is the large tenant here, tenant 201, can start to dominate the node. And what happens in that scenario? Well, the large tenant workload suffers because the performance goes down. But then to the noisy neighbor point, everyone else on that node can suffer as well, right? And their performance goes down and you get a whole bunch of surveys filed. So another cool thing we did is we have a function that enables you, if I go back to those shards and just remind ourselves that we've got 32 shards, I can actually take that tenant ID value, tenant 201, my big noisy tenant, and I can physically isolate this into its own shard, again, without any interruption to the traffic. And so what I've effectively done is, you can think of it almost like filtered replication in a sense. If I take a look at my shard count again, I've got 34 shards. What I did is I took the shard that had tenant 201 in it, and I broke it into three pieces. I took the values of tenant 201, and then everything above it and below it in the range. So that's why we have 34 and not 33, right?
Right.
And what I can actually do now, and I won't show this here, but what I can actually do is I can physically place those shards onto dedicated nodes in my cluster. And so you can create a situation where in a single cluster under a single connection string, without any change to the app, and while it's running, I can have some nodes that are hosting maybe hundreds of shards. So really densely packed multi-tenant resource sharing, super cost effective. But I can have another node which has got one tenant on it. And Cosmos DB will just figure out how to run those queries, as opposed to provisioning a whole bunch of new servers, putting stuff here and there, different connection strings, application level sharding, which is hard to maintain. We think this is going to make it much easier for developers.
That's really cool. I mean, that's why when you live in an apartment complex, you have a clubhouse in the middle for the parties. And so somebody's having a party in their apartment, you say, hey, you need to have your own space for this party.
That's right.
We're going to put you in your own little area and you won't bother your neighbors. I love it. I can't believe you did that in production.
We're moving them without interrupting the party, of course.
Yeah, exactly. Just pick them up, teleport them. I don't know, transporter into the other room.
Exactly.
That is absolutely brilliant. Very cool. So then what about doing this globally? Was all of that happening entirely globally? And what if something went wrong in the middle of it?
Absolutely. So this is happening on the way we're running at the moment is you can imagine on a single region. But what can actually happen as well is, and again, if we build off that SaaS example, when customers are starting to connect from different parts of the world, latency becomes a reality, right? Like, I mean, this is not a problem that's going to be solved easily. It's physics. It takes time to traverse the Atlantic Ocean, for example. And so I've got a different demo actually that I want to show you for that as well. And I'll cue off, if you remember how Kirill showed us, the map of the world. It's a famous, part of the experience of Cosmos DB to go and put those regions around the world. what I've got here is it's actually a Windows Server virtual machine, and I've got two console apps. The app that I just showed you was sitting in East US 2. And I've actually created a replica already, because it takes a little bit of time to provision in West Europe. And so what I want to show you here is, if you imagine that I'm a user and I'm sitting in West Europe, if I'm trying to connect to East US 2, latency is around about 80 or 90 milliseconds, right? Which, I mean, it's not a lot, but when you think about sort of the populating websites, the responsiveness of search engines, particularly if these queries are sequential in how they run in the app, it adds up. You're at almost sort of half a second here, and it could be more. With the replication capabilities that Kirill showed in the portal, I can actually replicate my data into West Europe. And so now if I'm that same customer and I'm refreshing the same page on the app, you're looking at 1 millisecond, right? And so that ability to effectively build the app once, scale it globally with Postgres, and then building on all of those other properties I showed about sort of online elasticity of scaling out tenant isolation, enables you to sort of build these Postgres-based applications at global scale very quickly and efficiently.
That is so cool. I mean, when I got into software, I wasn't thinking about the speed of light because the cloud didn't exist. But, more and more you bump up against physics, and it takes 8 minutes for the sun's light to get here, and you can only get database records across the Atlantic Ocean and so fast. So why not just keep them in Europe if you're in Europe? And that just makes a great experience for your customers. That's 40 times faster. And you just did that through configuration and smarts and the magic of Cosmos DB.
Exactly right. Exactly right.
Absolutely brilliant. That's a great demo. Thank you so much.
You bet.
Charles, let's bring Kirill back in. That was cool, man. I mean, you always bring the cool people to show me cool demos. I love it.
Charles is the best, but Cosmos DB for PG is even better.
That's right. And this is all general availability. So all this magic you're showing me, we have this today.
That's right. Let me show you where to read more about it. Let me bring the screen. Just like with everything else, Cosmos DB, you can learn about it here on our documentation page. You can try Cosmos DB for Postgres as of the time of you viewing this episode. It is generally available, and we'll keep adding more capabilities. You can try it absolutely for free. No Azure subscription is required. You can launch Cosmos DB for Postgres, play with it for 30 days, keep expanding it. All capabilities are included. And really take advantage of this marriage made in heaven between the most popular database tech out there, Postgres, and the world's best in terms of reliability, performance, latency, and scalability database platform, which is Cosmos DB. Together, I look forward to what apps you will build on it.
Very cool. This has been fantastic. Thank you both for hanging out with us today. Man, oh man, I am learning all about Cosmos DB for Postgres, about global apps and sharding and disaster recovery and all this stuff powered by Cosmos DB today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it, watch more Azure Friday.